The announcement is calm. That is what makes it unbearable. A scientist at a podium, reading carefully from a page, explains that an object has been tracked for several weeks, that the orbit is now confirmed, and that the probability of impact is no longer a probability. It is 100%. Then they give the date. An asteroid, several hundred meters across, is going to strike the Earth. Not in a film, not in 1,000,000 years. On a specific day that is now on the calendar. This is scenario 0. Today, could you survive an asteroid impact? The solar system is not empty. It is full of debris, rock and metal left over from the planet's formation. Most of it orbits harmlessly. But some of it crosses the path of the Earth. Size is everything in an impact. An object a few meters across burns up as a harmless fireball. An object a few tens of meters can flatten a forest. An object several hundred meters across. The scenario today is what scientists informally call a city killer. The destructive power of an impact does not come from the asteroid's weight. It comes from its speed. These objects strike the Earth at tens of kilometers per second, far faster than any bullet. At those speeds, motion itself becomes an unharmful. When that object hits, all of that energy is released in an instant. A several hundred meter impact releases energy measured in thousands of megatons, far beyond any weapon ever built. One number frames this entire episode. The destruction is regional, but the consequences can reach the entire planet. In the final seconds, the asteroid enters the atmosphere. The air cannot move out of the way fast enough. It compresses violently in front of the object, heating to a brilliant glow. For a few seconds, the sky itself holds a second sun. Then it strikes. The asteroid and the ground it hits are both vaporized and blasted outward. An impact crater is excavated in seconds, a bowl of shattered, melted rock that can be many times wider than the asteroid itself. From the impact point, several waves of destruction spread outward. First, a blinding thermal flash that can ignite fires far from the crater. Then an air blast, a shockwave of compressed air that flattens structures across a wide radius. And the ground itself shakes with the force of a major earthquake. But the most dangerous consequence is not the blast. It is the dust. An impact hurls an enormous quantity of pulverized rock high into the atmosphere. The finest material can spread around the entire globe. And, like the haze of a great eruption, it dims the sun. This scenario has a feature no other scenario 0 has. Warning time. An asteroid does not arrive without notice. If it is detected in advance, the world has weeks, months, sometimes years to prepare. Detection minus several months. The orbit is confirmed. The impact zone is narrowed. First to a wide region, then, as tracking improves, to a corridor, perhaps a few 100 kilometers wide. Everyone inside that corridor now knows they live in the path. Detection minus several weeks. If the warning is long enough and the will exists, there may be an attempt to deflect the asteroid, to nudge its path just enough to miss. Humanity has tested this capability. But deflection needs years of lead time. With only weeks, the impact cannot be stopped. It can only be prepared for. Detection minus 1 week. The corridor is being evacuated. This is the largest planned evacuation the scenario allows. And unlike a hurricane, the threat does not weaken or turn. Everyone who can leave the impact zone should. The warning is the gift. The only failure is not using it. Hour 0. The impact. For anyone remaining within the inner zone, survival is not possible. For those who evacuated or who live beyond the blast radius, the first event they experience is the flash, then the ground shock, then, minutes later, the long, rolling arrival of the air blast. Hour 72. Within the impact region, the destruction is near total, and the area is cut off. But the world beyond is not destroyed. It is, from this point, beginning to grapple with the second disaster, the one that is not local at all. A several 100-meter impact devastates a region directly. But its longer reach is the dust. And the dust does not respect the impact corridor. It belongs to the whole atmosphere. Week 1. In the impact region, the situation resembles the worst of the channel's other scenarios, combined. Blast damage like a great storm, ground shaking like an earthquake, and widespread fire. Aid, as always, is slow to reach a zone this severely damaged. Week 3. Globally, the sky has changed. The dust veil dims the sunlight reaching the surface. For a major impact, this dimming is significant enough to cool the planet and to disrupt the normal rhythm of the seasons. Month 2. The agricultural consequence begins. Dim sunlight and cooler temperatures across a growing season reduce crop yields, potentially across multiple continents at once. As with a volcanic winter, the gravest global threat of a major impact is not the blast. It is the harvest that does not come in. How deep this global effect runs depends on the size of the impact. At the smaller end of the city killer range, the cooling may last a season or two. At the larger end, it can shape the climate for years. The honest framing is that a regional impact can cause a global agricultural aftershock. Recovery from an asteroid impact has two separate timelines: the regional and the global, and they heal at very different rates. The regional recovery resembles the aftermath of a great earthquake or a direct hurricane strike. The impact zone itself, the crater, and its immediate surroundings, is permanently altered. But the damaged areas beyond it can be rebuilt over years, the way any disaster-struck region is rebuilt. The global recovery is the slower of the two. The dust veil thins gradually as fine particles settle out of the atmosphere. As the sky clears, sunlight returns to full strength, temperatures recover, and growing seasons return to normal. But during the dimmed years, the strain on the world's food supply is the central global problem. This is the honest scale of the scenario. A city killer impact is a regional catastrophe with a global shadow. It is survivable, genuinely survivable, for the vast majority of humanity who live far from the impact corridor. But the years that follow would test the resilience of the entire global food system. So, the question this episode has promised to answer: could you survive an asteroid impact? The honest answer depends almost entirely on one thing: geography, and then on how well you use the warning. First, if you are inside the announced impact corridor, the single most important action is simple: leave. Use the warning. Unlike a hurricane, an impact corridor does not shift away from you. The danger is certain. An orderly, early departure from the zone is the entire survival strategy for the people most at risk. Second, if you are outside the impact zone but within the wider region, prepare for the air blast and the ground shock. At the announced impact hour, stay away from windows. Shattering glass is a major hazard of the blast wave. Shelter in an interior room. Treat it, in those minutes, much like sheltering from a great storm. Third, for the long, dimmed aftermath, the preparation is the channel's familiar list, stretched toward the long end, because this aftermath is measured in seasons. Water. Shelf-stable food, a deep supply, because harvests may be reduced. A hand-crank radio. Flashlights and batteries. A full first aid kit. A long supply of essential medication. Cash in small bills. And, if you can, the ability to grow some food of your own. And the last thing, as always, is not a supply. It is community. An impact is one of the few disasters the whole world sees coming together. And the regions that would cope best with the dimmed years afterward are the ones whose communities cooperate, sharing food sharing labour, growing what they can, and caring for the vulnerable. A continent facing a hard season together endures it. A scattered, isolated population does not. How likely is a city killer impact in your lifetime? Here, the honest answer is reassuring, with one important caveat. Impacts of this size are genuinely rare. On average, a several hundred-metre object strikes the Earth only once in many tens of thousands of years. And there is a second piece of good news. Unlike earthquakes or eruptions, impacts can be seen coming. Astronomers actively scan the sky for near-Earth objects. The large ones, the truly civilization-threatening sizes, are now mostly found and tracked. It is the mid-sized objects, the city killers, that are still being catalogued. So the honest framing is this. A city killer impact is one of the least likely scenarios this channel will ever cover, and one of the few that humanity could, with enough warning, potentially prevent. We include it because it defines the role of warning itself. The reminder that the most powerful survival tool in any disaster is knowing in advance that it is coming. We do not run this channel to scare you. We run it because the most useful question a person can sit with, periodically, calmly, without panic, is, what would I actually do? Not in theory. On the day, the date goes on the calendar. If you found this scenario useful, subscribe to Scenario Zero. We are going to spend a lot of time in the dark hypothetical, so that in the bright real, you are slightly more ready than you were this morning.